So as we go through and we are learning about how to assign oxidation numbers to elements and compounds, you're going to follow these rules here, but you're also going to use your periodic table. Guys, there's a few rules that you've got to just kind of memorize. That if you just use your reference packet, your periodic table, it may not work out the way. Because notice, do they all have just one oxidation number listed there? Most of them have multiple. And specifically, guys, if you look over there toward the right, like those nonmetals, how many do they have?
3 or 4.
Yeah, they typically have 3 or 4. So just by looking at it, you may not know which one you're using. Okay? So that's where these rules come in handy. Nitrogen's got a ton. So does chlorine, arsenic, tellurium, selenium, bromine, iodine. What's that? This is table... Is there a table? It's not even a table. It's just the periodic table, right? If you go to table S, it's right before that. Oh, you're fine. So, there's kind of 8 rules, guys. Really, it's kind of 7. We're going to kind of talk through them first, and then we're going to do some practice, and you'll start to see the more practice you get, the easier this is, and you'll start to see some different tricks kind of start going. The first one is the most important one. If you have an element by itself, meaning it's not bonded to anything else, it has an oxidation number of 0. Okay, a pure element, meaning if you saw it listed there, it would just be something like gold plus another compound. Okay, so it's just a single element in a reaction. It has an oxidation number of 0, meaning it can either go to positive side or negative side. And that's going to be one that you will look at when we start doing oxidation reduction reactions. Okay, so that's kind of the first one. This is the one that people forget the most because we don't use it a lot. Hopefully we will continue to drive it home. But today what we're going to do is we're going to practice assigning the numbers within a compound itself. So that's why this one tends to get forgotten. And then we start doing reactions this week. That's when we will, this will come back and I'll see, I can be like, oh, gotcha. I'm looking for that gotcha moment. So prove me wrong. Don't let me have a gotcha moment with you. And rule number 2, the more electronegative element in a binary compound, what does binary mean? 2 elements. Is assigned the number equal to the negative charge it would have as an anion, guys. So this one, the more electronegative element, where, for review, we got that big exam coming up very, very quickly. 2 months from today, actually. 2 months from today is our Regents exam. Nope, I lied. Friday. It was 2 months from Friday. So less than 2 months. Where are the more electronegative elements? They are. Fond of the 3 most electronegative, but generally speaking, this is a periodic trend. To the right and up. Those are the most electronegative. This is where the arms, I do a lot of arms throughout the year, but this one, the bromine boogie. All right? So, prom's coming. You can use that, right? There you go. All right. The less electronegative atom, guys, is assigned the number equal to the positive charge it would have as a cation. So what are we trying to do? We're trying to, most of the time, do most compounds have charges with them? Let's just kind of start there. Think about it. If I write out H2O, does it have a charge? Meaning, what's the overall charge when they're all added together? 0, okay? So they become neutral. We've talked about that with bonding, okay? So you're trying to get them all to add up. Well, the most electronegative atom would have its charge. Typically, when you go to your periodic table, it would be the first charge. Okay, the first charge that's listed there on your oxidation numbers. That's the one it would normally have if it was the most electronegative one. And then the other one, you'll start doing some math to balance those out. Okay. Number 3, fluorine. Always has an oxidation number of -1. Why? What's unique about fluorine? It's the most electronegative element. So that falls in line with rule number 2. Fluorine's always a -1. If you take a look, guys, on your periodic table, okay, fluorine only has one oxidation number, -1. Okay, -1. Number 3, or rule number 4, guys, oxygen has an oxidation number of 2, -2 in most compounds. Almost all. There is one specific example that you need to be aware of. That's when you have a peroxide. Peroxide, guys, I believe if you look on your polyatomic list on, well, what table is that? It's table E. Okay, table E. Peroxide, take a look. Peroxide has this formula right here. O2, 2 minus. So if we go to figure out what's the charge, guys, on one of those oxygens, what would it be? Look at the overall charge is a -2. How many atoms do you have? 2. So to get those to add up to -2, what does each individual one have to be? -1. Because a -1 plus a -1 equals a -2. Okay? So if you have a peroxide, like H2O2, this would be the one that I would anticipate you seeing on your exam in June. All right? It's got an oxidation number of -1. When in doubt, I tell my students, go with -2, because 98% of the time, it's going to be a -2 when you see oxygen. Okay, but if it specifically says something with peroxide in it, like H2O2 or another peroxide, make sure you are aware of that. Also, when oxygen is in compounds with a halogen, like fluorine, fluorine's always a -1, guys. That trumps this rule number 4. So if you had something as OF2, oxygens would then be a +2 because fluorine has that -1. It supersedes oxygen. As we go through, you will start to see different examples when we go through this process, and you'll start to kind of pick up on that. Right now, we're just kind of reading through these rules, and we'll make more sense of them as we go along. Rule number 5, hydrogen has an oxidation number of +1 in all compounds that are more electronegative than it. It's got a -1 when it has compounds with metals. So most of the time, hydrogen is going to act as a +1. If it's with a metal, all right, that's when it would have a +1. And if you look on your periodic table, okay, you've got both +1 and -1. And notice, guys, the +1 is the first one that's in the upper right corner on your periodic table. The first one is the most common state that you will see. Take a look at your periodic tables right now. Wherever you see multiple oxidation numbers, guys, that first number is the most common one. Doesn't mean it's always that, but it's the most common one. So when in doubt, you can kind of guess that. Rule 6, the algebraic sum. What does sum mean? Addition. So they all add up to 0. We just talked about that a couple minutes ago. Rule 7, the sum of the oxidation numbers in a polyatomic ion is equal to the charge of the ion. This is why we write them with parentheses, and why we drove that home early in the year, that when you have a polyatomic, you've got to have the parentheses, because that negative charge distributes to everywhere inside of it. Rule 8, rules 1 through 7 apply to covalently bonded atoms. However, oxidation numbers can also be assigned to ionic compounds, but these rules are specifically talking about covalent. How do I know if I have something that's covalent versus ionic? Okay, how do I recognize covalent versus ionic? Covalent, how do I know it's covalent? What? In covalent?
In covalent, ions are shared in ionic.
Okay, but how do I recognize by looking at it? Alex?
Their gases, they're covalent.
What? Two nonmetals. Covalent is all nonmetals. Ionic is metal and a nonmetal. Basic chemistry here, all right? So, let's jump into some practice here, guys, and just take a look. The first example that you have there is sulfate. Does this do us any good right here? Having a name?
No.
No, we need a formula. Now, where could you look? You've got to know what sulfate is. It's a what?
Polyatomic.
It's a polyatomic. So we're starting right off with that polyatomic piece. What's the formula? Which is it? It's going to have a big difference. 2 minus. And that makes sense. It does matter, guys, because now we have a charge. So everything inside the parentheses, has to add up to that -2. That's what rule number 7 is stating, that the algebraic sum of all the oxidation numbers has to equal the charge of the ion. Okay? So let's start breaking this down. We know that one has to be positive and one element has to be negative, because that's the only way that they're going to be able to add up. Which one of these elements is going to be the negative, have the negative oxidation number? Why oxygen? There's a couple reasons why. Okay, oxygen is always going to be negative, but what's the reason behind the why that it's going to be negative? It goes back to one of the other rules that we talked about.
It's on the right side.
meaning it's what? It's okay. It is an anion, but it's further to the right side, meaning it's more what, guys? Electronegative. That's the reason why oxygen and fluorine will always be negative, is because they're the most electronegative. Notice even though nitrogen is one of the most electronegative, it can actually be forced to be positive. So those other two are in a world of their own because they're so electronegative. Okay, that's the reason why they're going to be negative. So when you see fluorine or oxygen, you know it's going to be negative. And typically, oxygen is going to be negative too, except that special case. So the way that I start to show my students this kind of make sense and show work is you're going to split it up. Okay, we know that because one's going to be positive, one's going to be negative. We'll talk about ternary compounds later on. Oxygen, we know, is going to be negative. Okay. How many oxygen atoms do I have? Well, I have 4, right? What's the charge on oxygen 98% of the time? -2. This is not a peroxide. So what's the total charge that oxygen brings to the table? -8. Okay? So we've got to figure out, well then, what does the charge on my positive, my sulfur, have to be to cancel that out? Notice, guys, sulfur has 3 possibilities here. -2, +4, and +6. We know it can't be which of the 3? Negative. Okay? So it is either +4 or +6. What's going to dictate that? What does the overall charge here have to add up to when you add them together? -2, which means which one has to be your oxidation number? +6. Okay? So how you would rewrite this for your oxidation numbers? S has got an oxidation number of +6. What's oxygen's oxidation state? -2. Good. And the reason why I stress that is because some people are like, oh, it's -8. No. The total charge that oxygen has with all of its atoms is -8. But here, we're just asking what's the oxidation number for a single atom? For a single atom. That's what we've done here as so. Okay? So it does matter what substance we're dealing with. Sulfite, the SO3, that can change it up. Why don't we do that? I know that's not in your notes, guys, but let's do that right now. Okay? Okay? No, I'm talking about sulfite. That's not sulfite. Okay? We'll get to that one in just a second. This is an extra one. What's sulfite? Right, and how do I know, guys, if I have a polyatomic or not? What's the way I can recognize that with the name? What's the sound that you hear at the end of every polyatomic, pretty much? 8, that T sound. It's either 8 or I. And remember, which one has the greater number of oxygens? 8 is bigger than I. Ide is cyanide, right? And that's one where, right, no, sulfide, typically when it ends in IDE, it's just the element by itself. Cyanide is the one example where if you looked on the periodic table, there'd be nothing that looks like cyanide, so you'd look as a polyatomic. All right, let's take a look here. Same idea. Right, and peroxide and hydroxide, there's a couple. Those ones we've used a lot more, so you can kind of recognize that, is the hope, okay? We've got how many oxygen atoms? 3. All right, its charge is going to be -2, so it's got a total charge of what? What's the total charge, the sum of all my charges have to add up to? -2. So now, with this one, what does sulfur have to be? It's going to have to be a +4. So our oxidation number here is +4 for sulfur, and for oxygen, it's what? -2, because again, it's asking you for single elements, guys. The single oxidations are not the total that all the atoms combined are. So that's our process there. Notice that one oxygen makes a difference. It changes sulfur's oxidation state. It goes from a +6 down to a +4 just by changing one oxygen. So it does matter that you have the charge. It does matter that you have the right formula. That will change your answer up, so you've got to be careful as you're going through those. Let's take a look at the next one. It looks very similar to our last one, that sulfite. But what's the big difference here? There's no charge. What's the name of this compound? Good review we're throwing back in there.
Sulfur trioxide.
Right, sulfur trioxide. So this is different. This is one, if you go back, if you were to look at old quizzes, guys, when we did naming, people just think, or like one of the labs, I forget which one of the practice sheets that we did, a lot of people just put sulfite down for this. It's not. It's sulfur trioxide because there's no charge. So it's not a polyatomic ion. So if we take a look, we split this up. All right? Oxygens, what's the charge in oxygen going to be? -2. So we got 3 times -2. That's for a -6. What's the total charge have to be here? 0. Because it's neutral. There's no charge given to you. There's no charge written there, guys, so it's neutral. What does sulfur have to be in this case? 3 plus 6. Again, you guys have a guide on your periodic table, so this should help it go a lot quicker as you go through it. So sulfur is +6, oxygen is -2. All right, -2. I want you guys to take a shot at this one. What's different now about this compound?
3.
It's 3. Try it. See if you guys can. Now, what elements here, guys, in this, you got to identify which is going to be negative and which is going to be positive. All right? So, how many elements are going to be negative here?
1.
1. Which one?
Oxygen.
Oxygen, guys. That's typically going to be the way. You're only going to have one element that's going to be negative. The rest will be positive, okay? So you just got to kind of realize that and think about that. Oxygen. What's its charge? Again, 98% of the time, when in doubt, it's going to be -2. Okay? And the reason, and to be honest, seeing that they put -2 as for oxygen's only charge, guys, on your periodic table, I would anticipate that's them saying you're never going to see a peroxide. All right, excuse me. We'll do an example and show you like that, a couple of the main, big peroxides that it could be, just so you guys are aware. But chances are it's going to be -2. So what's the total negative charge we have in this compound? By the way, what is this compound? Yeah, well, it's sulfuric acid. If I put AQ there, right? If not, it's just hydrogen sulfate. That's what I was going for, though, was sulfuric acid. I just want to kind of point that out, though. All right, so now we've got 2 other elements. Right, that's what I was going for, yep, and I wanted to stress that it's got to have aqueous to be an acid. So what's the charge going to be for the other ones? Now we've got to think about it, okay? The total is going to be +8, but we've got to kind of dictate and kind of split that up amongst all the different elements. Think about it this way, guys. Alex, you want to say something? Absolutely. So you guys know which one they are, but I want to just kind of point it out. If you think about it, what are the only 2 possible charges that sulfur could have for positive charges? +4 and +6. Does +4 make any sense here dealing with that hydrogen's the other one? Because what can hydrogen only be? +1. So you have 2 of those. So you have 2 times +1 for a total of +2. Well, when you think about that, that means what does the other one have to be? +6. So you guys kind of see, I know I'm stressing a lot of different things here. It's not as complex, but this is very important. You've got to kind of be able to identify this, because this is going to lead right into us looking at those reactions. So if we were to draw our little box here, what's the oxidation number for hydrogen? +1, sulfur is, and oxygen is -2. Okay? Are there any questions, guys? 2 times 3 is 6. So I've got 6 oxygens times -2. I have a total of -12 for my charge. And everything's going to add up to 0. So we know calcium, you have 1 calcium. It's a +2 charge.
Wait, how did you get that it all adds up to 0?
Do you see a charge on calcium nitrate? Like up here. That's how you know it adds up to 0, because it's neutral. There's no charge. Okay? So now, how many nitrogen atoms do I have?
2.
You've got 2. Okay? So guys, you could make a little equation if you wanted to. To figure out the math, you could probably do it all in your head, and that's great. You can make an equation. So we have 2 times x. All right? So then this is going to be 2 plus 2 times x minus 12 equals 0. So if we were to look at this, 2 and 12, we'd have 2x minus 10 equals 0. plus 10 plus 10. 2x equals 10 divided by 2 divided by 2. So x we know is plus 5. You can all probably do that in your head, right? Probably did. If I went through that equation a little fast, I can simplify it, make it slower for you. Plus 5 is what nitrogen would be. Again, you also have your chart to look at. You know it's not going to be any of those negatives. So you have plus 1, 2, 3, 4, and 5 of those charges. Just start plugging them in. Only one will actually satisfy that. So if we look at it, calcium, plus 2. Nitrogen, plus 5. Oxygen, negative 2. There we are assigning our numbers. So it seems easy. It's not that bad, guys, but it's very important. You have to be able to assign numbers because then starting tomorrow, we're going to start looking at actual reactions and writing half reactions where it's all about the charges. All right? Any questions?